doing it live.
I need to whip out a calculator.
Pretty easy.
Can I whip out a calculator?
Yeah, without a calculator.
Wow.
They're making out in body bags because they snuck out.
12 root 3. Because root 3 is left over, but everybody else has a pair, right?
Your head's in the way.
Wonderful. Right, 2, that's 2 squared. 2 squared rooted is 2. That's 2 squared rooted is 2. 3 squared, 3. Root 3, root 3. All right, a lot of talking going on, not a lot of work being done. You guys need to know this crap. I know in here, for a lot of you freshmen especially, you think because we don't have homework and stuff, you don't actually need to know it. But then the quiz comes up and it kicks your ass, right?
Yes.
Kids that have been in here for more than one semester with me know this all too well. Which is why they take this seriously. At least most of them do. Okay? So if you're new, don't wait and be dumb like those kids and figure out the hard way, right?
We all figured out the hard way.
Yeah, every single last one of you did, right? It's like that joke about falling out of the ugly tree, you hit every branch on the way down, right? You guys thought, it's fine, and you hit every branch on the way down to learn your lesson, right?
The one branch we didn't hit was quiz 1.
Exactly. You're like, quiz 1's easy, this is fun.
Some of us hit quiz 1.
You're like, hardest math class, whatever, right? And then you learn.
I got like a 90.
And I warned you, I was like, guys, quiz 1 is going to be a joke. Don't, yeah.
I got like a 90.
That's what I got.
All right, give me a factor of 1, 1, 2, 5. 5 definitely has to go in it. Now, in our heads, what's this divided by 5? Well, that's 25 divided by 5 is 5, right? Let's take care of that first, right? What's 100 divided by 5? 20. So we have 20 plus 5, which is 25. What's 1,000 divided by 5? 200. So we got 225. 25 was 5, 100 was 20, 1,000 was 200. Add them all up, right? 5's done because it's prime. It has no other factors other than 1 in itself. 225 we can do some work on. 5 and 25. 25 times 4. Oh, hold on, that's not right. That's not right. 25 times 4 doesn't work because that'd be 100. That'd be 125. Why is it 45? Does that sound right? 5 times 40 is 200, right? So 5 times 45 is 225. Are we done?
No.
No, we're not.
9 and 5.
I can break down 45. That's not prime. 9 and 5. Am I done?
No. 3 and 3.
Awesome. So we broke this down in what we call the prime factorization. Remember, factors are numbers that multiply together, right? To make another number. Prime factorization means broken down into the prime numbers that multiply to one number. Now, what's interesting is that every number has one unique prime factorization. Every number. They have a unique prime factorization. So 5 times 5 times 5 times 3 times 3 only is 1125. And that makes sense, right? You wouldn't expect it to equal 2 numbers, right? So this is 5 cubed.
Can't see it.
3 squared. Another way to think of it, right? Well, we got 5 cubed here. 2 of those get out, right? Well, two die and 1 sneaks out in a body bag, right?
Well, one dies, 2 sneaks out.
Yep. The other gets trapped in there, right? He's left over. And then there's 2 3s. So both die. 1 sneaks out in a body bag, right? We cool with that? That's going to be 15. Root 5. We seeing that? If you're not sure what gets out, write it all out like we did here and cross stuff off, right? 2 5s, 1 gets out. 2 3s, 1 gets out. 1 left over 5. Okay? Question. Are we good with this? Parker, we all right? Okay. Now, what if you had something like this? That's a cube root. Now, for square root, it takes 2, right? Cube root, it takes 3, right? If you have 3 cubed, what's the cube root of 3 cubed? 3, right? 1 3 gets out. So let's break down 189. 9 goes into 189? How many times? Well, 9 goes into 180.
I don't.
20 times, so 21?
20 times, so 21, yep.
Please find one.
Yeah.
Is it a perfect root? No. One's going to stay in, right? What we have here is the cube root of 3 cubed times 7, right?
So only one stays out.
So, yeah, it takes 3 to get out, right? So 1 3 gets out,
7 stays out.
7 stays in. 3 times the cube root is 7.
I have a question.
Yeah.
If we add 2 7, we just multiply those together and make 49.
You could and put 49 in there. Yep. Yep. Yeah, go ahead. All right, put it away. Kobe. All right. We don't change it. It's not a joke. It's a respect.
Lonzo Ball.
All right, we're going to go back to this. It's using the quadratic formula. Super easy. Because if you need to find zeros, that's a good way to do it. Solving quadratic equations.
Divide 0.
We're on like 5, I think. Yeah, we're on 5.
Why would we use this? Good question. If I want to know when does this equal 8? Good luck, right? What number do I have to plug in to get 8? This is difficult, right? But notice, no matter what equation I have, no matter what number I have here, I want to find out when it equals 13, when it equals 12. Can I do this? And now I'm solving for zeros, aren't I? And that's when I use quadratic. Does that make sense? Every question I want to ask of when this equals something can be moved over all to one side and get me here. And now I'm asking when does it have zeros, right? Yeah.
What if it doesn't equal 0?
Well, if it doesn't, like this case, then just move it over and now it does.
Oh, okay.
Right?
Alright.
What? Yeah, because then you move the x over, right? What if I had this? Well, now I've got minus 4x here. You see how no matter what's over here, I can always move it all over to get 0 on this side? And then my question becomes, when does this equal 0? What is x when y is 0, right? And that's why we need the quadratic formula, because a lot of times it's going to be messy, right?
What if there's not a variable? It's like if you put y.
Like y here?
It's like,
Then we're not asking a question, right? We're stating an equation. There's lots of possible answers, right? Does that make sense? It'll represent a parabola, and we can graph that and show you all the possible answers, right? Yeah.
What's this problem where you can't add it over? Like, there's nothing to add it to?
Let's say it again.
Like, what if this problem where you can't add it over and there's like nothing to add it to?
Give me an example of that problem, and I'll tell you how to do it.
Something x squared equals 7 plus x.
Like that? Right? Right? Everything can be set equal to 0 if you work hard enough, right? And then the question becomes, what's the answer? Quadratic formula, right? When y is 0, what is x? All right. We stopped on 6?
5.
5, all right. I'm skipping 5
why?
because it's boring. What is the quadratic formula? We want to know what x equals when y is 0. And that'll mean what?
Negative b plus or minus root of b squared minus 4ac all divided by 2a.
Yep, all over 2a. Try number 6 on your own. Go. Nope, I'm skipping 5. Good. You'll need to eventually, right? When you turn it in. I can't make it any easier. So that's quadratic formula. Just real quick, for number 6, we said we were gonna do. Yes. What's our A, B, and C? What's A? Somebody give me A. Jace, give me A.
2.
Shambaugh, give me B. Tickler, give me C. Yeah, we're on number 6.
-20.
There we go. Get at it. In my geometry class freshman year, in order to annoy the teacher, we used to use the back of the cabinet in the back of the room that I sat by. It smacked as hard as we could and made a noise. Yeah, don't worry about it.
You number 6.
Maybe even C. Right.
But she had like I'm sorry.
Oh, yeah. This could be some of the easiest stuff we do. Because it's just plugging into an equation. You know the equation. If you don't remember the equation, you're easy to derive it. I don't care if the circle looks like a
Yeah, it really does.
It's fine. Like a curvy triangle, that's fine.
106.
Oh my god, that was something. That was Are we allowed to use calculator?
No.
Darn.
I mean, you can, but like you're not going to get to use them on the quiz, so you might as well.
Not use
Right?
them at all.
And again, how much better have you gotten in mental math by not using calculators this year? Kids that are here for the first semester. Yeah? You're freaking ridiculous when it comes to mental math. Same thing with you, Mitchell. Okay? Right? Most of you guys are. Most of my first semester kids are. Well, simplify it, right? Is 151 prime? If it is, then there's nothing more you can do, right?
I got lost.
Okay.
I stopped.
So we're going to say that x equals opposite of b. What's the opposite of b?
3.
Negative 3.
Well, I was just on the right.
What's b squared?
B squared.
Minus 4 times a. What's a?
2.
Times c, which is?
Negative 20 and a half.
What's double a?
2a. This is where I got lost.
A battery.
All right, let's simplify what all this is. That's going to be a positive answer, right?
160.
So whatever it is, it's going to be root 9 plus. That's 8 times 20.
60.
Okay? All right. What's 9 plus 160?
169.
Nice. And that's a perfect root, actually. It's 13. If you didn't have that one memorized, you do now. If you didn't have the root of 169 memorized, you do now. It's 13.
My favorite age old.
All right, one version adds 13, another version subtracts. Let's add first. What do we get?
10.
So 10 divided by 4, which is
10 divided by
5 halves, right? Yeah, I know. Jace, good answer. Good answer. Now, when we subtract, what do we get?
16 divided by 4.
Negative 16 divided by 4, which is?
Negative.
Negative 4. So we have two answers. You can write it like this,
Age just.
or you can write the coordinates, right? Because we know y is 0. So this is the answer, 5 halves when y is 0, and negative 4 when y is 0.
Did you just write the coordinates?
Yep.
Or get about?
Nope, coordinates is fine. Either way is fine. I just don't want you to be confused by the back. That's not a coordinate, right? The answer key, right?
I forgot the.
That's it. These are coordinates. Feeling okay?
Yeah.
All right, let's up the ante. Let's look at number 7.
Alright.
Give us super high numbers. 20,000.
Now let's take a look at the answer. This looks scary.
Oh, I think
Wait, is that 17? Sorry, my bad. I want to look at 8. Sorry, I thought 17 was 8. Or 17 was 7. Let's look at 8. It looks scary. But notice, it's just what we had before we did this, right? Right? That's 169. So we had negative 3 plus or minus the root of 169 over 4. This is something plus the root over 4. This is something minus the root over 4. All that means is that when they got their root inside here, it wasn't a nice root. Right? It wasn't a perfect square. That's it. Yeah, they just left it. That's an answer for number 8. Okay? But it should not be scary to you.
Will be somewhere back in the quiz.
So basically, you kind of do this in order, so just be.
That's why they just left it.
Or subtracted.
Yep, one with adding, one with subtracting.
Okay.
When you can't simplify because things are complex, you like that because it means less work. You can just stop there. So let's do number 8. Ocho. Together. I'm going to write number 8 real big. First off, what do you notice about this problem? We got to move this over because remember, we can only use quadratic formula when we're solving with y is 0, right? Logan, sit here because you're way too loud and annoying. Sit here. Not right now. All right, so we move it over first. Guys, I'm doing it not because I'm annoyed, but because other people in this room are getting annoyed by you. And they're right. They're right. Okay? And Preston doesn't care, but everybody else does. Okay? All right.
2. A equals 2.
So I moved it over. That way we're answering the question of when does this quadratic equal 0, right? And that's when we can use quadratic formula. It's when y equals 0. So whenever it's not 0, just move everything over until it is, right? Yeah.
Will you add the 10 over?
Ooh, good catch. Yeah, we added over, and it's going to be a positive 3. Negative 3. Negative 3. Sorry, I was distracted. All right, so A in this equation is what?
2.
Thank you. And B is? No.
7. Negative 7.
All right, guys. I don't kick people out of class because I think it's a waste of time. But in your case, it might make a difference. Because you need to realize I'm being serious here. You're annoying everybody else in this room, and it's my job to advocate for them. No, shut up and listen. Okay? It's okay. I'm not mad at you. You're not in trouble. I didn't give you detention, so there's no reason to argue because there's nothing to fight about, right? You're not in trouble. I'm trying to tell you. If you annoy them enough, I will remove you from class because they want to learn. Does that make sense? I think it does, right? Awesome. Awesome. I'm not worried about you learning, okay? I'm worried about them. And they can't with you guys being loud, okay? Negative 7 is B. Don't forget your signs. C is negative 3.
Negative 8.
And again, if you can't take me seriously, I will make you take me seriously, okay? I don't want to because I think it's a waste of time. But I'm willing. All right, so now we use quadratic formula. Right? We have the opposite of B, plus or minus the root of B squared, minus 4AC, all over 2A. We're only allowed to use this when we know y is 0, right? In this case, it is. So what is the opposite of B in this case?
7.
7. Very good. Plus or minus? What's B squared? 49.
14. Negative. What?
It's okay.
I can't talk.
What's A?
2.
And C is?
Negative 3.
Double A will be 4. Now if you look, if A or C are 0, right, then this goes away, and we automatically get a nice root, don't we? If A is 0, then we don't have an x squared term. So that probably will never happen, right? If it did, we're working with a linear. Why are we using this, right? If C is 0, because we have a 0 here, then this goes away and we get a nice root. Right? So whenever C is 0, we're going to get nice answers. That's kind of nice. All right, so now let's simplify. What's 49 minus 4 times 2 minus 3? Well, it's going to be a positive, right? 4 times 2 and 3. We have 6 times 4 is 24. Seven plus or minus the root. What's 49 plus 24?
74.
Nope, it's positive. Double negative. Cool. Now, 73 is not a perfect root, right? Well, we should check and see if we can simplify it. Because what if it's 4 root something? Well, then we divide by 4, right? Let's see if we can simplify it. 73 broken down. 9 and what? Oh, it's not. I'm thinking 72. My bad. 73 prime.
Yes.
How many numbers do you need to check before you can determine a number's prime?
5.
None.
All of them.
Let's talk about this.
670.
If I want to check if 73 is prime,
Yes.
right? All I need to do is check for any of the numbers that are less than root 73. Think about it. Let's take a number like 8. It has factors of, well, let's do it this way. 8 has factors of 1 and 8, 2 and 4, 4 and 2. You see how I got halfway and it doubled, right? I had the same thing twice. So halfway is going to be where I'm going to get numbers like this, right, where it doubles. I don't need to check the rest. I've already done it, right? Well, halfway for 73 is going to be root 73 and root 73 because root 73 and root 73 multiply together to make 73, right? So anything less than that is what I want to check. Anything less than root 73, let's estimate root 73. Well, we know root 64, right? That's 8. So guys, check it out. Root 73 I'm going to estimate. I know it's got to be greater than root 64, and that's 8, right? And then I also know root 81 is 9. It's got to be somewhere between 8 and 9, right? Yeah, it's a fraction. It's 8 point something. Right? So it's about 8. Let's check all the numbers up to 8. 1 is 73, obviously, right? 2 go into it? No. Does 3 go into it? No, because add them together, do they divide by 3? No. Does 4 go into it? No, because 2 would, right? No even number's going to go into it. Waste of time. 5 go into it? No, it doesn't end in a 0. 6 even doesn't count. 2 doesn't, 6 won't, right? What about 7? No, because it goes in 70. What about 8? No, because it goes in 64. Add 8 more, it gets 72, right? I don't have to check 9, 10, 11, 12. I don't check all those.
Maybe 8.5.
Right? It'll be 8 something, not right in the middle. It'll be 8 something. Okay? But the point is that this is a prime number. I know that because everything less than 8 doesn't go into it, and I know this root is less than 8. Does that make sense? Maybe about 50 or so. I only have to check up to 8. Because root 73, the halfway point where we turn around, right, is about 8. So I don't have to check any higher numbers. I don't check 9, I don't have to check 10, I don't have to check 11, right? I can stop after that. So I know that root 73 is prime. So root 73 is as simple as it gets, and there's my answer. Why make it more complex? You could estimate that, type it in a calculator, and you'd round it, and my answer would be more correct because you'd have to estimate, right? Why do extra work to be less accurate? That's 8. Both versions. You could write it out 7 plus root 73 over 4, right? And 7 minus root 73 over 4, or you can just leave it like this. It covers both, right? Let's take a look at, what's another crazy one? Take a look at 16. 16. First off, is 16 in standard form? No, so we need to get it that way and have it equal 0, right? Otherwise we can't use quadratic. So I'm going to rewrite that to this, and then I'll write it big on a different piece of paper. You follow me on that?
Yes.
Awesome. Guys, it's been much quieter since I had to make that remark. If you were being bothered or weren't being bothered by them, or whoever was talking, right? Can you say thank you for what they're doing now? Yeah. Show them that you appreciate it. All right. Cool. So, A is what?
9.
And B is?
-7.
And C is? Exactly. Don't lose your signs. Okay? So here we go. Opposite of b. What's that? Plus 7, right? Plus or minus square root of b squared. What's b squared?
49.
Ooh, 49. Very popular number today. Minus 4 times a. What's a? 9. What's c?
4.
Double a.
18.
18. All right. So, we got to figure out what this is. It's going to be a positive answer, right? Four times 4 is 16 times 9. What's 16 times 9? Better question. What's 16 times 10? 160. Subtract 16 to get 16 times 9, right? 160 minus 16. 150, 140, 4. Ooh, they're both roots. It's 7 and 12, right? Nope, it doesn't work that way.
You got Adam.
It doesn't work that way. Let's see what happens if we try that.
Addition.
If I say this is the same as 7 plus 12, I get 19, right?
Yeah.
That's going to be 100 and what? 180, 193? Root 193 does not equal 19. No way. 19, yeah, that's just not going to be it, right? So, can't do that. Got to add them up, and so they're one term, and then we can root it, right? Is 193 prime? Let's find out. We want to know if 193 is prime.
Yes.
So we need to check up to root 193, right? Let's estimate root 193. Give me a root slightly bigger than that, we know.
144. That's smaller.
That's smaller. We know 169. What's root 169? And again, you don't need to get as close as possible. Maybe you can think of a better one, right? What's root 200? You know that off the top of your head? Two numbers multiplied 200? No, you don't know that one. 110. That's true. What's a bigger root than you know 110? Well, this is 13 squared.
208.
What's 14 squared? Well, 14 times 14 is 14 times 10 plus 14 times 4. 140 plus.
Sorry, I'm slow
Okay.
today.
196.
Oh, it's 2 long.
Oh, yeah, it's 2.
So this must be between 13 and 14, right?
Or more near 14.
But very close to 14, right? So we need to check up to 13, right? That's all we can check. So 193, of course, but like that. Does 2 go into it?
No.
Nope, so none of our evens do. So I can skip all the evens. 3,
No.
No.
4 plus 9 is 13. 13 won't make 4. Not to the 3, right? So 3, multiple of 3 won't go into it either. So I don't need to check 9, right?
6.
I don't need to check 4 because 2. What about 5?
No.
That is 0 or 5, right? 6, don't need to check it. 7?
No.
What do we know that goes into 7, like close to that? We know 140, right? 147 would,
190.
right? 190 would. So 7 doesn't. 8, don't need to check it, it's even. 9, don't need to check it, because it's multiple of 3. 10, don't need to check it, it's multiple of 5. 11. 11 goes to 193?
No.
It goes to 121, right? Remember, 11 multiples almost always produce palindromes. So yeah, that's not gonna happen. 12,
No.
don't need to check, it's even. 13. Last number I gotta check.
No.
Nope, 13 squared is 169. Add 13, we get 182. Add again, we get 195.
We're close though.
Just all I know, right? So it must be prime. So we're done.
Yay.
Figure D.
Yes, you have to check and see if that's prime without a calculator. Don't check every number up to 193. Don't do that. Don't do that.
193
I
times
couldn't
1.
be able to.
know that you only have to check up to root 193, right? Because that's the halfway point.
Yep.
And that means any number less than 13. Less than or equal to. Do the rest of these for homework. Tomorrow we'll do something different. I want you to do them for homework, that way you can come up with questions. If you don't have questions, we'll move on.
Wait, what's the concept?
I'm sorry, what?
I don't understand the concept of self-development. What do you
Ooh, right, okay. So self-development is stuff that's offered at the end of quizzes, right, as extra bonus problems. There's also stuff like we do as a warm-up that I might say, like, if you want to expand upon this, I can give you self-development points. If you come in and visit me to get help before, after, or during school, I give you 2 points of self-development for that. So if you come in for help, right? Yeah, you've got a bunch because you've been coming in a lot.
How many do we need this?
You need 20 points per semester. Most of you guys have 0. Let me tell you what you have now. If you did stuff on Wednesday when I was gone, that's where self-development. I'll check the bin. I haven't checked the back bin. So I don't know what people have now after Wednesday. But here, hold on. Here's the total I have for you guys before counting Wednesday stuff. Okay?
Did you put the magic square in for me? Because that magic square, did you put that?
Yeah, I have it, but I will right now.
Those.
All right, here's the total. Lindsay has 0 right now. You might have some back there that I haven't checked yet. Logan has 0. Preston has 0. Ann has 6. Mitchell has 6. Jordan has 4. Josh has 4. Parker has 2. You probably have more than that. I just haven't put your self-development in. Cece has 1. Right?
CJ.
CJ, sorry when I do that. I have Cecilia written down and just totally threw me off. You're CJ because your middle initial is J, right? Guys, move.
Maybe you should change that.
I'm sorry. I should. Ethan, you have 0. Shamba, you have 7. Deborah, you have 0. Adam, you have 2. Olivia, you have 4. Jace, 0. Caden, 0. Lexi, 0. Lexi, I owed you self-development. You have 4.
I came in what?
Is that 9-6 without the magic square?
No, it's good.
Alright, next.
Yeah, because he was in the
Wait,
middle of
yeah.
helping me
Actually,
down.
I have
Can you-
8 because I came into.
Yeah, so I don't get some low points.
3 times.
I think I just upgraded you guys. I'll go back. Yeah, you should have at least like 12.
I didn't even have a few other blocks.
Yeah, you should have at least 12.
I didn't even know.
I'll go back and check. Algebra always falls in the back.
Here we go.
Yeah, I know. I know after last semester.
I know, I'm sorry.
You didn't get all the stupid finals grades, so like the day before.
I know. I'm sorry. That's how it goes, man. I gotta do geometry first.
Can we turn in our warm-up sheets right now?
Yep, you can today if you want.
Are we gonna have to
Nope. Yes. Yes.
Time passed.
You what? Oh, you do. Do it. Hold on.